Now I request NSS Jagidishwari and team from Kite College to present their paper. Paper titled Three-Phase PV Inverter Fuzzy Controller for Grid Connected System.
So, my name is Jagidishwari and I am from Kite College. We are from Triblim branch. Our project is about PI-based management of power for interconnected AC-DC microgrids.
Good afternoon, everyone. Thank you for giving this wonderful opportunity. Respected honors, all of HODs and CTPOs of KISS College. Thank you for giving this wonderful opportunity. My name is R. Sudhir Kumar. I am from Kite College. My project is PI-based management of power for interconnected AC to DC microgrid. The main contents of that project, abstract main objectives, introductions, we will discuss after. Okay, the main abstract of this project, mainly you already know AC to DC microgrid. A grid means it gives better power quality. Okay, we are connected AC and DC microgrid at a time. We have then obtained some operational drawbacks. That drawbacks is obtained from that microgrid. Then we rectify that drawbacks. We used specific conditions to DC microgrid. When we are used some specific loads to DC microgrid, then it gives power sharing. Power sharing and voltage regulation, not when both AC and DC microgrids cannot give at a time voltage regulation and power sharing. We used, for that purpose, we used different statistical schemes. These schemes give overcome power and better voltage regulations. This is the main abstract of that project. I am going to introduction. The main objective of this proposed scheme is to control the flow of power from AC microgrid to DC microgrid. Now I am discussing about introduction. In today, electronic management, we are used so many advanced technologies like control strategies and network topologies are used. Why using this networking topologies and the control strategies? It is used to determine the benefits of load requirement. Then that advanced technologies are formed grid. We are used AC to DC microgrid. So you saw AC microgrid and DC microgrid we are used for my project. Why I am using AC and DC microgrid? It gives better voltage regulation. Once we are used AC2 and DC microgrid, then one grid receives more power and another load receives less power. I am rectifying that problem. We are using tie converters. Okay, this is the main block diagram of interconnected AC and DC microgrid. We are using tie converters and utility grid, AC generator, solar PV, loads, and here DC grid, this is AC grid, and this is tie converters. Why I am using tie converters? Tie converters, it gives better voltage regulation and it gives, it provide power transformation from AC to DC. Okay, we are using droop controls for DC microgrid. It is used to better speed control of DC generators, and we are using solar power, solar PV, turbines and utility grids here. This is the main block diagram, and another topics are discussed with my friend.
As my friend explained, I will explain it in detail. Generally, our electrical system, electrical whole world is connected in the grid. Grid is generally interconnection between producers, source, consumers, and transferring systems, etc. We have AC grids, DC grids, and many grid systems.
So what is the main purpose of this block diagram? So this block diagram tell about the series of steps required. You can able to easily understand. If you required any suggestions, my side to give to importance of block diagram. Without importance of block diagram, the series of steps involved to make develop the block diagram. How can able to get the idea? The audience are no. Not aware the importance of block diagram. So you tell about the importance of block diagram.
Block diagram generally
What are the steps comprised involved to develop this block diagram? Okay. The series of steps are required. Step by step procedure is required. Then only you can able to easily understand the audience. So you are not get entire the order by steps. So tell about that order by steps and how to establish the block diagram. What is importance and significance of the block diagram? So such things are systematically. Then you can they can able to easily understand the importance of block diagram. Okay, carry on. Outer side.
Block diagram. So here we have AC grid here and DC grid here. Here we generate the power from AC. So here electricity is generated from AC. Generally thermal power stations generate AC power. And here in DC, PV cells generate DC power. So when we have any deficiency or deficit, power deficit, we use some converters like tie converters to convert power from one form to another form, from DC to AC or AC to DC. Generally, tie converter is a bidirectional converter where we convert AC power to DC and DC power to AC, where we are having deficiency of power.
Which component is required to convert AC supply to DC supply?
Converter. And this is bidirectional converter, so we can convert both AC to DC and DC to AC.
The which current is applicable to in the industrial related applications?
AC and both DC, based on the requirements, sir.
What is the behind the reason?
For charging batteries, like batteries, we use DC, and for some home appliances and for our general use, we use AC.
Flow of current representation in terms of AC current.
Sir?
The flow of current is having it is symbolic representation of alternate current.
I don't understand.
The flow of current is going on continuously or up and down, which behaves like as the alternate current.
With frequency, it is AC current, and without frequency, it's a direct current. So this is the block diagram of tie converter. Here we use some PI proportional integral converter. This is a control system block where we control output and we produce it to the input, so we can obtain the desired output.
Positive, negative is the charges of current. Positive, negative. Okay, so both are get it. That is a stabilized, right? That is neutral. Suppose the positive charge ions left from in particular domain, what happened?
Sir, once.
The positive charge ions are left in the particular region. What happened? So imbalanced.
Yes,
So if
sir.
you are balanced, negative charge left, positive is a, along with associated positive charge ions also moving along the
Yes,
negative
sir.
ions. So negative positive is nothing but cations, negative charge is nothing but anions.
Anions.
Okay, both are combined to make a stable. That is in charged, neutralized, right? So once positive left, along with associated same charged molecules are carried out. Okay, otherwise that is not stable.
Yes, sir.
If you are stable, both charges are maintained to maintain the neutralized. Then only the flow of activities are going on effective manner, right? Okay.
Here we use maximum power point tracking MPPT. So when we use a PV system, we have some issues like we will not have solar energy regularly, depending on the clouds, depending on the climatic conditions, season changes, etc. So we use this MPPT to get more voltage point. So whenever we transfer for AC to DC, we use some transformation techniques like ABC to DQ not transformation, which uses transformations to get the desirable AC or DC voltage current. PI controller is used here, so block diagram of PI controller is given.
So you are mechanical people or electrical people?
And also pulse width modulation is here used in this project. So about this pulse width modulation. So here pulse width modulation is a modulator which modulates the signals to the desired signals. It chops if necessary, and if it adds if it is necessary. Simulation diagram which is built in MATLAB.
Previous diagram, please show me.
Sir?
Previous diagram. After that. This wave like this. So how many components are appeared in this sinusoidal wave? How many components are appeared?
3, sir.
Wavelength, amplitude,
Yes, sir.
frequency.
Yes, sir.
What do you mean by amplitude regarding this picture?
Distance between top and
Not like that. The maximum displacement travel, the maximum distance from its mean position. Are you following that point? What is amplitude?
distance between.
No. The maximum displacement of a material or body from its mean position.
Yes, sir.
Where is locating the amplitude in this figure? See in this figure, you are addressing the amplitude. Where is the amplitude here? Show me. Where is the position? Where is the place of a amplitude about this configuration, this representation?
On the prepare all it, sir.
Huh? You don't know? Yeah, from peak level, the maximum displacement from its mean position. That is called amplitude. From that to here,
Yes,
that is
sir.
called amplitude. From initial position to end of the position, final position is called wavelength. Right? V equal to n lambda. Lambda equal to V by n.
Yes, sir.
V is the velocity of flow to velocity of sound. Okay, okay, right. Go ahead.
So this is the simulation design by using MATLAB. So here we used PLL and converters, pulse width modulator and etc. These are the results we obtained from MATLAB simulation.
After a simulation using a MATLAB, the y-coordinate represent on what component? What is the represented parameter in along y-axis? What parameter which are used to To plot this diagram, what is the parameter addressing the y-axis, on y-axis? Volts.
Voltage.
Voltage. Along horizontal axis?
Current.
Current. What is the behaves this curve? Like this. So up to certain point, where is the indication? Where is the units? You don't know. So this is just like linear. After that, the slope is gradually increase, suddenly increase. What happened? Why suddenly increase the slope between voltage to current? At that point is 1/4 the range of the entire size of the current. Are you following my point? Up to certain level is okay. After that, the slope is suddenly increased. Why?
DC generation increases.
The voltage increase, but slowly current is decreased. Okay, it means overall slope is increase. Overall slope is increase at the domain. At domain is suddenly increase the slope. It means the voltage increase with the minimum current. Overall voltage to current ratio is increased. What is the reason? What is behind the reason? Are you following my point? అంటే ఆ పాయింట్ వరకు గ్రాడ్యువల్గా మూవ్ అయ్యి అక్కడి నుంచి సడన్గా స్లోప్ ఇంక్రీజ్ అయింది. స్లోప్ ఇంక్రీజ్ అయింది అంటే అక్కడ అర్థమైంది వర్టికల్ యాక్సిస్ ఇంక్రీజ్ అయ్యి కరెంట్ యాక్సిస్ హారిజాంటల్ యాక్సిస్ డిక్రీజ్ అయింది. ఓవరాల్గా రేషియో అయింది ఇంక్రీజ్ అయింది. ఎందుకని? అదే ఇట్ ఇస్ మై క్వశ్చన్. ఏంటారు? ఇంకా క్లారిటీగా ఇవ్వాలి, క్లారిటీ చెప్పాలి. ఓకే చెప్పండి, తెలిస్తే చెప్పండి, లేదంటే carry on.
Because one grid takes heavy load, another grid takes low load. So that purpose the waveform signal is raised at peak level. We are using generation type converter power, then obtained these waveforms. This is obtained from simulation MATLAB diagram. Thank you. We are used solar PV. These two diagrams, two waveforms are DC microgrid with turbine, fuel cell, solar PV and load. When moves to this is the waveform. When moves to another slide, this is only used to turbine, fuel cell and load. We are not considered here solar PV. So these are the waveforms of DC microgrid.
Fast moving.
Now conclusion is we are used tie converters to improve voltage regulation, because when use AC and DC microgrid, then one load takes heavy load, one grid takes heavy load and another grid takes low load. This issue is rectified by using tie converters. This is the main aim of the project. Thank you.